Okay, so in this tutorial, I will show you how to use the console to open imaging data from any other source for which there's a Python library, as well as go through a bit of the internals of how the Mesmerize viewer works and the underlying data structures that the viewer uses. So let's open a console through here. And I'm going to open this image, which is just stored using numpy.save. So let's import numpy. Let's open that image. So copy path. Okay. And then we can see that this image actually has a shape of TXY. And if you look at the viewer core API for Mesmerize and go to image data, you can see that the image sequence must have a shape of XYT. So actually, if we just do a.t.shape, that will give us the right shape we need in order to create our image data object. And after we create the image data object, we can create a new viewer work environment object, which is what is used internally by the viewer. So let's do that. So besides the image sequence, we also need the metadata. So if you want to manually enter your metadata instead of using like an automatic loader like what you see here, this applies to that as well. So let's say meta equals let's say, so one key that's needed is origin, which is just for you to know where the data came from. Let's say it's my 2-photon microscope. Well, this is actually 1-photon image, but anyways. The sampling rate of the data should be stored as FPS. Let's see. So it's 10. And FPS is a very important piece of metadata for downstream analysis. Let's see. Date. And this has to be entered in basically year, month, day, and then hour, minute, second format. So I'll just do something for that now. And you can enter any other information that may be relevant to your recording. It's, I don't know, scanner position maybe. Okay, so there's our metadata. And now let's create the image data object. So in the viewer console, the namespace has certain classes that are already imported, such as viewer work environment and image data. These references can be used without you having to import them from Mesmerize. So let's create image data equals image data, which is exactly this object here in the viewer core API. And we want to use a.t from the numpy file that we loaded, and the metadata. Okay, we have our image data object. And now let's create a new viewer work environment. Or we'll set the current viewer work environment from that. So we can just do viewer.work environment equals viewer work env. And as you can see again, viewer work env is by default a reference that's in the namespace of the viewer console by default. And all we need to pass to that is image data. Okay, and then finally call update work env in order to update the GUI of the viewer with this new work environment. And there we have our image that was loaded from this NumPy, saved NumPy file. And this basic procedure of creating an image data object using a NumPy array with this axis order, and then using this image data object to create a viewer work environment applies for basically any image that can be expressed as a NumPy array and opened from any Python library, like for example, if you have imaging data stored in HDF files. Okay, sort of to give you an idea of how the ROI Manager backends work, I will show you how you can create some scatter ROIs if you are interested in creating an importer for ROIs that originate from different sources. So for the ROI Manager, there are a few different backends that are available. So there's a manual backend, there's a scattered ROI backend, which is basically read-only ROIs, and then there's a volumetric ROI backend, a volumetric CNMF backend, and a volumetric CNMF, a regular CNMF ROI backend. And all of these three backends just subclass from the scattered ROI backend. So for CNMF and CNMFE use the CNMF ROI backend. The volumetric CNMF uses this backend, and the Suite2P imported ROIs just use this backend directly without there being specific subclass for it. So I'll show you how you can use this backend in order to create some read-only ROIs. So first, let us get the ROI Manager. So we can see all modules that are available through that. And then get module ROI Manager dot start backend, and then we can give it scatter ROI for scatter ROI backend. Okay, and then as you can see with the message here, ROI Manager backend set to manager scatter ROI. It's getting a bit crowded. Okay, so let's create a new scatter ROI. So, the scatter ROI Manager backend contains an ROI list. And well, first of all, we can access this backend by doing get work env dot ROI Manager. And please note, this is different from this. So this will give you the GUI module, and this gives you the backend. So you can see that, and we can see that that's, that backend is running. And if we do ROI list, it's empty because there's nothing. Okay, so let's create an ROI and add it to the list. So there are different ROI types, and each of these types is only compatible with their respective backend. So the scatter ROI type is only compatible with the scatter ROI backend. The CNMF ROI type is only compatible with the CNMF ROI backend. So let's create a new scatter ROI. So let's just import this first. So from Mesmerize viewer.ROI Manager modules ROI types import scatter ROI. might try a way to expose these namespaces better. Okay, so there's our scatter ROI factory. And let us create a new scatter ROI. So we need to, or actually there is a simpler method for doing this. Sorry, I did not script this video tutorial ahead. We can just directly use the manager scatter ROI backend to add ROIs. Yes, sorry. So this part was not necessary. So let's create a new ROI. So I'll just create a function to make a bunch of circular points. I just got this from Stack Overflow actually. So, yeah, okay, that should give us circles. Let's try one circle, say 5, 15. Let's create it at, let's say, a position of 100, 100. Oh, import numpy. Ah, right, we need to import numpy in here actually. That should be cosine. Okay, so there are some coordinates for xy coordinates for a circle, and so this method add ROI of this manager scatter ROI backend basically takes x and y points for the ROI and curve data, so intensity values. So as I mentioned before, so this backend is for creating read-only ROIs. They're not ROIs that you can move and which will automatically update from the underlying image data. This is used if you want to import, if you want to create an importer to import ROIs from some other tool that does signal extraction. Okay, so let's get our backend. Add ROI. Okay, so for curve, let's just do curve equals numpy dot arrange, you know, whatever length this is. That should work. Actually, that should work actually. Okay. equals np.random.rand 2,999 points. X's equals cores, the circle that we just created, of Y's and no metadata for this ROI. And if you have df over f data or spiking data, you can enter those as well here as arguments to, or keyword arguments to actually the ROI Manager.add ROI. Right there. So, well, we have one very tiny set of points that were added. Let's create a bigger circle. Say okay, that's not actually how this function should be used. Did I make this correctly? Sorry, so other way around. There, we have a little tiny circle there. Okay, let's create a larger circle. There. Sorry, this took a few minutes. Yeah, so here I just had a function to get some x and y points, and you can feed the x and y points to this function, add ROI of the manager scattered ROI backend, and give it the curve data that's associated to that, and the ROI manager will basically use that information. So this is an example of how you can interact with the ROI manager backend. So let's say you have maybe some spiking data as well. Let's say spike data. Let's maybe find some other numpy function that might be useful. Oh, let's just do numpy.rand 299, or actually I'll do arrange 299. Okay, so here this is another ROI that we just added, this one here. And if I go to spikes, as you can see, that data is handled, taken in by this argument here. And it would be similar for any delta f over f data that you would want to set. Oh, and lastly, you can set tags as well using the console. And actually, let me just open a project to show you how to do that. We'll need to create a new viewer. Let us just open some image file. Oh, wrong metadata loader. All right. So let's get the same function. Let's create that circle. And oh, we need to set the ROI Manager backend module ROI Manager start backend scatter ROI. Let's access that backend. Spike data. Okay, so there's an ROI. Oh, forgot. Yes, this does have something that we can annotate. Yeah. So we have this ROI now, and so we see that in the list. Let's actually add another ROI. Let's maybe create a smaller circle. Say inner circle. There, another inner circle. And yeah, so you can see we have 2 items in this ROI list. So ROI list, let's take a look at this one. If we click on this, we can see that no information is tagged to this. we can also view that information here. So dot types scatter ROI, and yeah, get all tags. That will return the dictionary. And we can also set tags using set tag. So S2P is cell, say some ROI label. Oops. Yeah, you have to give the ROI def here and tag to label it with. Okay, there. And let's just set the second one as this, the other ROI. Okay, and as you scroll through this, you can see the labels onto it. And we call get all tags, you'll see all the tags that are available. And if you have more ROI defs in the project configuration, it works in the same way. Alright, and that's basically all the methods that would be useful for if you wanted to create an ROI importer from some other type of source. So this would be the same API that you would work with, like setting tags. If you wanted to, for example, map ROIs to some atlas based on their position. So within the ROI list, you can actually get the X and Y position of the ROI for each one within the list. So actually, if we just do, yeah, this one, we can do get state. What is it actually called? ToState, sorry. Right, ToState. And that will give you a dictionary with, let's just, oops, sorry. That will give you a dictionary with basically all the information that's associated to that ROI. So for instance, let's dock this back in and do ToState and then ROI axis, and that gives all the X points that delineate the ROI, and ROI Ys will give you all of the Y points, and of course this contains, you know, basically all the other information that is associated to that ROI. And yeah, this is, for example, perhaps how you could write a script in order to iterate through your ROI list, and based on perhaps the center of mass of each ROI, you could tag them with some label. And everything that you're seeing here in the console works exactly the same through the script editor. So when you use a script editor and run a script, it just gets dumped into the console. So like, for example, let's say, let's just do for ROI in our list, ROI dot set tag, say S2P is cell, just do enumerate let's say you want to name it as ROI number plus that, for example. Okay, say we have something like that, and you go to run. As you can see, that just gets dumped here, and as you can see, they have been labeled with their number from this script. So similarly, you could do something where you get these ROIs, and perhaps based on ROI X's and based on ROI Y's, you might want to find perhaps their center of mass, and based on that you could maybe map them according to some atlas. And as I mentioned, each of these ROIs can contain, or the ROI Manager can contain metadata. So, I mean, there's nothing set in here, but this can basically be a dictionary, and perhaps you could use this to store information that maps the pixel values to coordinates in an atlas, and then you use this map that you have in your metadata to map these onto your actual atlas. And yeah, so this is basically an overview of how you can use the Mesmerize API to interact with the ROI Manager and a few other things.